As we continue through some more verifying trigonometric identities, we'll get through several examples here. I do know that I skipped number 11 here. I wasn't planning on doing all of them, so 11 got skipped. Just trying to give you these examples so you get a feel for what's going on and some things to look for. So coming to number 7, we're going to choose the more complicated side. I would definitely say the left side is more complicated here. Use identities, factoring, distributing, adding fractions to simplify one side. Now, just thinking through this, how can you multiply 3 things together to end up equaling 1? Well, one way to do that is if everything would cancel out. And so maybe everything cancels out here. So that's kind of my thought to start with. So in this case, I'm going to try to put everything in terms of sine and cosine, because every trig ratio can be written as something related to sine, cosine, or both. So here we go. So right from the start here, secant, I'm going to change. We know that's from our reciprocal identities, that is 1 over cosine. Sine is just sine, so sine theta. And cotangent, now I know one big one is that tangent down here is sine over cosine. That's really one we should have memorized. And if we have that one memorized, we can easily know, because of our reciprocal identities, that cotangent of an angle is cosine of the angle over sine of the angle. So I'm going to rewrite this cotangent as cosine theta over sine theta. Well, what did I use here? I used a reciprocal identity, and we used a quotient identity. And now we actually just see we have some things that cancel. So cosine cancels with cosine, and sine cancels with sine, and we're just left with 1. So we got to what we wanted to get to. We got to 1 is equal to 1. That was simplifying or canceling. And that's it. Sometimes they turn out to be really easy. All right, number 9. Number 9 actually is going to be easier to prove later once we have a couple more identities that we haven't talked about yet, but we can definitely get to it from what we have here. If we try to pick a side that's more complicated, it's kind of a toss-up. I don't know. Well, we have 2 terms on one side, on the left side, 2 terms on the right side. So we can just pick a side. It doesn't really matter which one. Most of these we have started with the left. So it's good enough reason to start with the right, I guess. Change it up a bit. So we are going to start with the right side and see if we can turn it to the left side. Now, as mentioned before, whenever we see squared functions along with a 1, we probably want to look to Pythagorean identities. So let's see what we have here. So I'm looking over here at Pythagorean identities, and I do see a cosine squared with a 1 here. And so what I'm going to think that if, a couple different ways to think about this. I see a negative 1, so I kind of want this to be a negative 1, so I could subtract 1 from both sides and subtract sine squared from both sides. So once again, I'm going to subtract 1 from both sides and sine squared. So that would give me cosine squared minus 1, sorry, I went over top of my line here, is equal to negative sine squared. Well, do I have a cosine squared minus 1? Well, this is 2 cosine squared theta. So to start with, I'm actually just going to write this as cosine squared theta. What does 2 cosine squared theta mean? Well, that means we have 2 cosine squared theta. So all I did was use my definition of multiplication is repeated addition. So I changed 2 cosine squared theta into cosine squared theta plus cosine squared theta. However, now I see what I just mentioned. Here's cosine squared theta minus 1. What was that equal to? That's equal to negative sine squared. So using that Pythagorean identity, barely fit it in here, I'll just write Pyth identity. We can say cosine squared plus negative sine squared. And that's really what we wanted to show. I know it's plus and negative. We know it's the same as subtraction. So that is one way to work through that. And we'll stick with that. All right, number 13. So number 13. Both sides look fairly complicated, but I would say the left side is more complicated because it has something times a couple terms. So what I would do here is I would probably think, well, maybe if I multiply these, if I go ahead and distribute, because over here I have two terms, so maybe I can multiply and it will also be two terms. So we have, when we distribute, we have sine theta plus sine theta times cosecant theta. And that was just simply distributing. That was very sloppy. Distributing. Now notice we have a couple things. We want a sine theta. We have a sine theta plus something. So this is plus 1. Does this second part equal 1? Well, sine times cosecant. What's cosecant? Well, cosecant in a reciprocal is 1 over sine. So a number of times its reciprocal is equal to 1. I'm going to throw in an extra step just so you see it. So we could write it like this. Using the reciprocal identity, we know cosecant is 1 over sine. And then we really see they cancel. But as we get better, if we ever see a trig function times its cofunction, that also reduces to 1. So we have sine of theta plus 1 equals what we were trying to show, sine of theta plus 1. And here, this second step here, we used a reciprocal identity. And then we canceled or simplified. Let's put simplify. All right. Number 15. Definitely the left side's more complicated. We want something to multiply together to equal 1. So what I would probably do is I would look here, and kind of what we mentioned before, cosine squared theta times what would equal 1? Well, cosine squared theta times its reciprocal would equal 1, and the reciprocal of cosine is secant. So I'm just trying to talk through this to help you put some things together. Also, another thing we mentioned, whenever we see a squared, think Pythagorean. It might not be, but it often is, especially if it has a 1 involved. So coming over here to our Pythagorean, I'll highlight it in pink here, 1 plus tangent squared is secant squared. So we can take out that parentheses part, 1 plus tangent squared, and we can put in secant squared times cosine squared is equal to 1. Right there, we used a Pythagorean identity. And then, if we know secant and cosine are reciprocals, they can just cancel. If you want to show a little more work, we can write that secant squared theta is 1 over cosine squared theta using our reciprocal identity. So that's using reciprocal. Then obviously we see that cancels, and so we have 1 equals 1. We simplified that or canceled. And there's a few more examples of some trig identities, verifying trig identities.